All right. So now we have, let's see, a 360 Newton force is applied at A. So I'm assuming that force is P. And we're asked now, well, what are we asked? We're asked, what's the moment of the force about D? Okay. The moment is all going to be R cross F. What it is for everything. So R cross F. So we have a force here. And we can split this into sine and cosine. So we're going to have force in that x. And we're going to have Fy. And the force here is going to equal 300 and that was 8. Should be 306 cosine of 25, and this one should be 306 sine of 25. And let's see, what do those equal? Well, let's get a calculator. I will pause my video. Hold on, I have to go downstairs and get my calculator. All right. 306 cosine 25. I don't know, would that be in kilonewtons or something, maybe? Newtons, okay. And then that same thing, but sine. Okay, so now we kind of have this force split up into a force here and a force here. Now, finally, we can start thinking about this problem. Now, I don't really want to think about too much like, oh, this hinge here is going to rotate like this about this point, and this thing's going to swing here to here to here. I feel like you can really get into the weeds quick if you try to think about stuff like that, so I'll try my best to not. And instead, to just stick with the basics of what is a moment. It's a force times a distance. And to overcomplicate it, that's silly. So we really just need to know enough to solve the problems, and the hard work will take care of itself. But we also have to know that it's not just a force times any distance, it's like a force that's perpendicular. You know, you can't take a moment about something that's doing this. You'd have to take the moment from here to here. So in that sense then, we'd only have to think about what it would rotate after we find out what exactly it is we're measuring. What's this have to do with anything, by the way? That's kind of throwing me off. Point C? No, they're asking about point D. So we've got an R. The sum of the moments about D. This is going to be the distance of 200 times the force of well, it's going to be Fx and Fy. Fx is going to be rotating this counterclockwise, so it's going to be a positive. And we know that Fx is 277.33. This is going to be minus going to be a distance of... Oh, there's something interesting about that, isn't it? Distance of... I'd like to say 200 meters Fy, but that's clearly not going to be the case. Even though Fy is 200 meters, this is in line with what the force is, so it's got to be 100. We're going to have 100, and then Fy, which is 129.32. And those really are the only forces now. We have Fy and Fx, and the distance between them, and the point. Then the moments here are going to equal 200 times 277 minus 100 times 129. And I'm getting 42533.91 newtons. This is actually going to be newtons times meters. I apologize. Let's see. 42533.91. No. Let's think about it. We have this force times this distance. That's correct. We have this force times this distance. That's correct. This force here is positive. This force is negative. That's 100. It's 200. Of course, those are in millimeters, and it wants the answer in meters. I think this might be it. So then what's the millimeter to meter? Let's see. Would this then be... Yes. Okay. This would then be 42. This is millimeter. This would then be 42.5 newtons meters. So that is how you do problem 1 for statics chapter 3, all about moments.